managing secrets, I mean passwords, certificates, and keys. That kind of thing that you want to provision to your application at runtime in a way so as secure as possible. So I'm just wondering, who here does DevOps? Hands please. So that's just 5 people out of 15. So the rest of you guys, you have like an operations department deploying your code. Is that correct? Okay. Just wondering, those doing DevOps, do you think you publish your secrets in a secure way to your applications? Yes. Do you change them frequently? How often do you change them? Not at all? When somebody leaves the team? Mad? Not at all? Never, ever? Okay. Can people see them? Yeah, but do people have the rights? Okay. So there might be some team member or ex-team member which has copied the secrets and still can access stuff at runtime. Okay. So let's see. Let's see if we can try to avoid that using a change. The point I'm trying to make is we're coming from a scenario where we have this, all right? Developers creating code, building code, creating binaries, and just handing it off to other people who wonder about all the secret and key stuff. And they just magically make it work, and it's their responsibility to operate it securely. And now we're moving to DevOps, where in a lot of cases we developers expand our responsibilities to operating and deploying code. And we're not really aware how we do that in a secure way. And I think we should. And that's what I will try to talk to you about today. So what do you want to achieve when you're talking about secret management? I think there are 4 things. The first one is there are no shared secrets, no shared credentials. So there shouldn't be a single root account that 4 people have the same password for. You want everybody to have his own personal account. Secondly, you want the principle of least privilege, which means not everybody should have a root account. Everybody should have only an account that allows him or her to do what he or she should do, and no more. Thirdly, no team member should ever have standing production access. In a perfect world, there's only one thing that has access to your production environment, and that's your DevOps pipeline. That pipeline is responsible for putting both your code and your secrets in that runtime environment, and nobody should ever have to be there. Of course, you as a team should have some means to elevate yourself in production if the case arises, but there should be no standing access. It shouldn't be necessary. And finally, in a perfect world, you want to decouple authentication from authorization. So authentication is establishing who you are. I'm Henry. And authorization is saying what I can do, for example, in a conversation with somebody. And when you're talking system to system, you can separate these 2 out as well. So we have a user directory, for example, Active Directory or LDAP, that can establish who I am, and give me some kind of certificate, token, and I can use that to go somewhere else where they decide what I can do. So you want to separate those 2 out. Also, that's also the case, especially when you're talking about applications doing stuff. And these are 4 important principles in my opinion, and I'm mostly going to focus on the last 2, because we're talking about system-to-system authentication. So what I want to do is take you on a journey, because storytelling and taking people on journeys is hip. So I want to take you on a journey through 4 approaches for managing your secrets and providing them to your applications at runtime. And I labeled them 1 to 4, so they're more important stuff. So by now you might be wondering, who's that guy? My name is Henry. I'm a freelance, independent Azure dude, big nerd. I've used .NET and Azure stuff for about 5 years now. And when possible, I try to share back to you as what I can. I'm also one of the ALM DevOps Rangers, which is a group of 140 people worldwide who are trying to provide professional guidance to the community, so you, on how to do DevOps in a great way, which includes secret management. So let's dive in. Approach number 1. When you start doing DevOps, one step back. I'm going to share 4 approaches with you for doing secret management. And each one is going to be more awesome than the one before. Why don't I start at number 4? Well, the reason is every approach has some requirements that you have to fulfill, which is harder than the requirements for the approach before. So you're going to explore all 4 approaches. You're going to see if approach 4 is fitting my scenario. If not, you're going to try 3. If not, you're going to try 2. Also, what I'm going to tell you, I'm going to demo on Azure with VSTS. Most of the principles should also translate to other clouds and other release orchestrators. So let's assume we have a simple web application which does nothing more than just showing a secret on screen, in this case bank account password, and we're developing that application on my laptop, and we also want to release it into Azure using an Azure web app. Well, the first way to get secrets into that application at runtime is using my release orchestrator. And then I mean VSTS. So who here is familiar with VSTS, or TFS, or continuous building and releasing? That's 1, 2/3. No, just 1/3, I think. Okay, well, I will show everything after I introduce the approach. So what we're going to do here, we're going to take all our secrets and we're going to store them into VSTS, which is going to act as our key ring. And VSTS is going to get our sources, going to compile them, generate our binaries. We call this an artifact. It stores that artifact. Now we get into releasing. And in a release, we pick up this artifact and we just fold in the secrets just before we do the actual deployment on the environment we want the application to run on. So VSTS can do this, but for example, Octopus Deploy can do this as well, and there might be other orchestrators that you're using that can probably do this as well. So when would you use this? The scenario for using this is probably when you're just doing continuous deployment of your code. You have an existing infrastructure, which is either just there, you haven't created as a team, or it's even something you cannot change or are not allowed to change as a team. So somebody is provisioning an Azure Web App and say, well, there you go, that's the place to deploy your code. Might even be on-premise, just an IIS server. So let's take a look at what that looks like. Unless there are any questions so far.
If you have a question, I will throw this box at you, don't be scared. It's the microphone, it's for the live stream, so everyone can hear you. I forgot to tell that you will start.
Oh, thanks for making sure there will be no questions. So what I'm going to try and do is...
It's really fun.
Okay, I'll take your word for it. So, what I'm going to do is I'm going to show you a really simple ASP.NET application that I've developed. I'm not a front-end guy, so what I did, I just created a ASP.NET application out of the box, took the default generated view, threw everything out, and just put in one sentence, sharing my bank account password, and then just echoing that into the view. The controller that's backing this view just does one simple thing. It gets that password from my web config. So this is a normal way of handling things that you want to change per environment, right? Now when I run this locally, that's going to take a while, we will just see the value that's in web config echoed back to the screen, like we would expect. Now what we want to do in our production environment is change the value of this secret that's popping up right about now to something else than development value. So this development value, this is in source control, which is probably a thing you don't want as well, but that's not the thing I'm going to cover today. So what we can do is we can use VSTS to get our code into an existing app that I'm showing here, which is not useful at all. We can use VSTS build to just compile our application. Fantastic. We can use VSTS build to just compile our application and stash the binaries that we are generating into what we call an artifact. That's everything that I'm doing in VSTS build. What's more interesting is what I'm doing in the release, which I prepared here. So I'm going to pick up the artifact that I've generated in the build, going to deploy it to a production environment, which is just a really simple deploy consisting of one step, which is an Azure App Service deployment. And what I'm going to do here is override the bank account password value in the app config. And for that override, I am using a variable bank account password, which is a thing you can define in VSTS as well, right here. And the thing you will notice is that this value is masked. So I'm using VSTS as a secure store for my secrets. Now, if you're doing this on-premise in TFS, you might be wondering who can access this. But if you're doing this in a hosted environment, this is pretty secure, and there are other people in charge of keeping it secure, so you don't have to worry about it anymore. This is the first step in secure deployment. Now you might be thinking, what if I have a lot of applications and I want to share secrets between them? Well, the thing we can do is we can create a library of variables and secrets. So if you want, you can have just one centralized location with all your configuration and reuse them in different releases. Is this clear? Awesome. I paid the designer, I think, $50 to use this image, so let's enjoy it for a second. So, what did we get from this approach? Well, it's by far the easiest way to get started with secure development. It's also a thing that would fit really well when you're having an existing situation where you as a team get an existing infrastructure, maybe an existing code base, and gain the responsibility of secure deployment of your code to that environment. And your secrets are pretty secure. The cons though, you have to get those secrets somewhere and copy and paste them into VSTS. And of course, I do know we all just move KeyPass files around, but in practice, let's face it, we're probably using email, text messages, Skype to business things, which are actually encrypted, so that's not as bad as the rest. Another thing we're getting is when we're accessing our Azure web app in production, which we shouldn't, but if we do, all those secrets are there in plain text. So that's also a disadvantage of this approach. And another thing, which is related to the thing that we're duplicating secrets, is that we cannot change secrets easily. And I mentioned this at the start because it's a thing we, as developers, aren't really considering. But if we want to be really secure, we have to roll our secrets every now and then. There's a thing called an advanced persistent threat, so that somebody has reason, for example, our service, and if we never, and we pick up secrets. And you just have to pick them up, be there for like 10 seconds, remove all the evidence, and be gone. And then you can keep using those secrets forever and ever. But if we roll them every now and then, we make sure everybody that has gained access in some way will be kicked out again. It's especially useful when you have mad people leaving your team. So let's quickly take an intermezzo and see what you have to do to actually roll secrets in a secure way when you're doing something like this. Well, first of all, I'm going to assume you have like primary and secondary secrets. That's the thing you get out of the box for almost every Azure service that's using keys. It's also a thing you can do yourself when you're generating accounts. You can create 2 accounts for your system. And what you can do then is only use the primary secret, primary key in your application. And when you have the need to roll the key, you can start using the secondary secret, do a release. So in production, you're using secondary. There you're going to change the primary secret. You're putting that in your release orchestrator. You're doing another release, so now you're using the refresh primary secret, and then you can roll the secondary secret. And then you're sure all secrets are changed and nobody can have can retain access. So that's quite a procedure. If your release takes like 10 minutes and you build 5 minutes, you're close to an hour on the way. And you don't want to do that every week, for example. So this is suboptimal. But this is a thing you can do. So let's dive better, which is using ARM templates. Who here is familiar with ARM templates and actually using them in production? In testing? Okay, some people. But you're actively using them?
Not very much, you just started.
So you just
started.
Just started. Okay. Well, ARM templates are a way to describe in a declarative manner what you want to have your infrastructure in your Azure environment look like. So you can just write JSON, which says, I want to have a storage account, and I want to have a key vault, and an Azure web app, and a VM with 2 NICs and 1 network connection. You can specify your complete infrastructure this way. What you get from that is that you are now in control of your infrastructure. And by creating that storage account, you are also creating the 2 storage keys. And you can use those keys that are being generated by deploying that infrastructure and provision them automatically as app settings to your application. Another thing you can do is provision a thing called a key vault. Everybody knows what a key vault is? Okay. Really quickly, the Azure Key Vault is a hosted key ring. So it's a secure place, even with hardware encryption, if you want to, that can store secrets, certificates, and secure files. No, just secrets and keys, sorry. And what you can do is you can just echo things from that key vault into your app settings as well. So if you have keys that are being generated by deploying a storage account, you can echo them to your application. And if you have, for example, third-party secrets to access a service that's outside of your control, you can put those into that key vault and provision them to your application as well. So when would you use this? Well, the same thing as before. When you're using a continuous deployment of your code and also doing a continuous deployment of your infrastructure using ARM templates. So again, this expensive picture. Let's take a look at what that looks like. Wrong button. So let's start with taking a look at these ARM templates. And let me stress this, if you aren't using ARM templates, do start using ARM templates. It's like really the best thing ever in cloud development in a while, in my opinion. Because it relieves you of the duty of going into your testing environment, pressing create storage account, waiting for a couple of minutes, then moving to your acceptance environment, pressing create storage account, and then doing the same thing in production, and just figuring out that your naming convention just prevented you from creating the storage account in production and going back to testing. Aside from that problem, once you have a description of what you want your infrastructure to look like, you can reliably deliver that to your testing, acceptance, and production environment, making sure that everything, and really everything between those environments is exactly the same. So you're not having a thing called configuration drift, which is a real problem if you're working a lot on the same application, especially in a post-development, more bug fixing and mitigation stage of your product lifecycle. I think there's one person with operation in background, and you probably recognize this. So what is such an ARM template? It's a JSON file that consists of 3 sections. Resources are JSON descriptions of Azure resources. This is the representation of a storage account. And here you can directly see what the parameters are doing. You can declare them at the top and reuse them in the rest of the template. And the parameters are the things that you can vary between environments. So that's the thing that's being configured for testing, acceptance, production, etc. Now, variables are the same thing, but you declare them in the file. So that's, for example, when you're retrieving something out of the deployed infrastructure, or when you want to concatenate 4 parameters. Here, I'm deploying a key vault. Like I said, a key vault is a key ring in Azure. And it's a thing where we can securely store keys and secrets. And we can use those in two ways. The first way is we can reference them from our ARM template and use them during deployment to echo, for example, app settings. And you have to enable your key vault to support that. So there's a property called enabled for template deployment, not to confuse with just enabled for deployment, that allows Azure to use secrets in that key vault for rolling out an ARM template to your subscription. Next to that, there's an array with access policies that allow you to define which keys, defined by a unique GUID, in a specific Azure Active Directory is allowed to do things on keys and or secrets. And in this case, I am allowing, I think myself, to do everything. But you can, for example, just allow one application to put secrets and another one to just retrieve secrets. So that's principle of least privilege applied. And there are a number of SKUs. And the main difference is software encryption versus hardware encryption. Hardware encryption is really, really expensive. And I do trust Azure and Microsoft blindly to do this better than I would ever do myself. But in a lot of fields, there are a thing called compliance, and you have to have hardware encryption of keys. So this is what an ARM template looks like. Are we all on the same page using ARM templates? No questions? Thanks again, Eric. So now what can we do? There are a lot more resources I'm deploying here, and one of them is an Azure Web App. And nested within this Azure Web App resource is another resource which has the legendary name App Settings, which is just a name versus value list of app settings that are pushed to my web app. And here I'm showing you two different kind of things. The first one is that I'm using a parameter of my template file and using that as an app setting. The second one is that I'm using an ARM template function, which is used within these square brackets, to reference a resource that I'm also deploying in this template, and then list its keys, which are the storage account access keys. Then the first API version I'm using, I'm referencing the primary key, its value, and I'm echoing that into the app settings. Of course, this is all lookupable on MSDN. So that are the two ways that I can get secrets to my web application. I've been talking a bit about those parameters. You might be wondering where do those come from? Well, next to this template, there are a number of parameter files that you can create, one per environment. And this is the place where you supply all the values that you need. For example, the name of the key vault I'm using. As you can all see, this is my Active Directory and this am I. I'm defining names, SKUs. So for example, in my testing environment, I have just one core simple VM backing my web app. In production, it's a much larger VM. But this is really interesting when it comes to secure development. What I'm doing here, I'm not just providing a value, I'm referencing a key vault in Azure and a secret in that key vault. And at runtime, or at deploy time, Azure will retrieve that secret and provide it to the template, and it will go to the app settings. First, this is all done in Azure. So the secret will never ever leave Azure. It's amazing. Sorry. I don't know. Let's take a quick look at the pros and cons of this approach. No, they are still visible in the portal. So that's a nasty thing. So the value will be visible, yes. If you have, yeah, the value will, because the value is actually echoed in the app settings.
And it will be echoed because you gave your user account that right?
No, the one that's deploying the ARM template has to have the right to deploy that template. Yeah, that's VSTS still doing in this case, yes. So, but we don't have to do it manually anymore, so there is less secrets passing around in even more unsecure ways. And we're reducing the application of secrets. Rolling them still isn't easy. So let's quickly dive into a much better approach, which is kind of what you were hinting already at. What if we could have our application directly access the key vault to retrieve the secrets when it needs to? Because then we don't have them as app settings anymore. So what we want to do is basically this. We're deploying stuff to Azure, have that web app retrieve its secrets when it needs to. But to do that, we first need to give our application a runtime identity. It has to be able to identify itself. And that kind of gets us in a loop, because to identify itself, it's probably going to need an app ID and a secret. Why do you keep that secret? Well, not in the key vault, because then you would have to have an identity. So there's a thing called Managed Service Identity in Azure that is just a box you can tick, and that when you do, Azure will automatically provide an identity in your Active Directory, and when your app runs, it will run under that identity. So that's fully managed. And then, of course, we can get that application's GUID and provide that access to the key vault. And we can have our application retrieve secrets when it needs them. Now, when would you do such a thing? Well, you have to do continuous deployment of your infrastructure and your code. And this is like a shitty thing. You need to have permission, because now you're providing an identity to an Active Directory. And if you have an old-fashioned systems admin, you're probably going to get into a fight. So this is a thing about where you're starting to realize you're part of a bigger organization and you have to comply with rules that are applying to everybody. Also, Managed Service Identity at this point in time, which is May 16th, I checked yesterday, is still not generally available. So you're using a preview service and probably...
On that portal, documentation of that, they still suggest create an Active Directory, use a client ID and client secret to talk to...
Yes, because the thing is really simple. Everything that's not GA is not backed by SLA, so if you're advising that, you're liable. That's probably the story. If you're allowed to use GA stuff because you're a lean, mean developing machine, do it at your own risk. You might be wondering by now, what do I do about local development? Because now I got this runtime identity in Azure, but how do I do local development? Well, there are three ways. The first one being the best one. And that's if you're working as a developer at the company and the machine you're working on and the account you're logged into is in an Active Directory, which is synced to the Azure Active Directory, that's linked to your Azure Key Vault and your subscription. You're all in the same domain, so you can have your developer account access the Key Vault for the development environment only. This is definitely the best solution. If not possible, you can do what I did in my example. You can just create some code that detects if your application is running in Azure. If it does, it gets stuff from the Key Vault. If it doesn't, it gets stuff from webconfig. That's a little bit of code you have to write and test once, but after that point you can just switch back and forth from your code. And thirdly, you can create an identity in the Active Directory yourself, retrieve an app ID and a client secret, get that into the webconfig, but never ever ever get that into source control. Because when you were just connecting to a local DB, well, it wasn't cool to get secrets into source control, but people probably couldn't access the database. But now you're checking in secrets that can be used to obtain an identity that is allowed to access stuff in the cloud from everywhere. So this is really important. Let's take a look at what it looks like, if everybody's clear on the approach. So, the first thing we have to do is give identity to our application, right? So let's look up my app service and see the tremendous amount of things that I have to do there. Yes, there we go. Ta-da. That's it. I'm just going to declare I want one. In the portal it's the same thing. It's just a thing you have to tick. The first time this ARM template is deployed, that identity will be provisioned to the Active Directory, and you can pick up the object ID that's related to that identity and give it access to the key vault. You can also use another function similar to list keys to get a reference to this web app and do something like .identity, .principal ID, and just reuse it from within the same template. So you don't have to do manual steps in between. So you can reuse the identity you're creating here directly in when you're assigning access policies to your key vault. That's everything to get identity to our application and give our application access to the key vault. So then we're going to need some code to retrieve the secret. But first we have to decide if we're running in Azure or if we aren't. So I've made this tremendous function that just checks the existence of two environment variables which are documented. So this is not some kind of hack. This is actually the advised way to check if you're running as a managed service identity. And if I am, there's a thing, the Azure Service Token Provider, which is in the packets azure.webapps.keyvault.something that you can find on NuGet. I instantiate this thing, I instantiate a key vault client, and I get a secret using the full identifier of the secret. And this is a thing that I can check into source control, because there aren't any actual secrets here. Some people might argue that it's not secure to store where your secret is. Let's not have that debate right now. And if it doesn't work, I'm just going to echo something back from my local environment. So if I run this, I'm just seeing my web config value, and in Azure, I'm going to show you at the same time. Let's not do that. We will see the production value. So here we're seeing a value that's directly retrieved from Key Vault, and here we're seeing still the development value. So no more moving around of secrets. So why is this cool? Well, all the things we had before, no more manual stuff, no more duplication, but also secrets are no longer visible in the portal because they're not in the web app. They are just in the memory of the web app, and you can do that in a secure way. The cons, quite simple, it's not GA yet, and also it's only available currently on Azure Web Apps. So if you're using Service Fabric, it's a no-no, and if you're still using worker roles and web roles, it's a no-no. As far as I currently know, there is also not a competing offer in, for example, AWS or the Google Cloud, or there even is an IBM Cloud. Yeah, sure. Generally available. Sorry. People who work a lot in Azure, there are things like GA, which are generally available, which is a backing SLA. So there's like a guarantee from Microsoft that it will be up like 99.9% of the time. And there's stuff that's in preview. Well, the cool stuff that's in preview, but there is no SLA, so you're probably not allowed to use it in a corporate environment. Yeah, sure.
So you said that it's web apps, and Azure Functions are kind of web apps, right?
Yes.
I assume that it's also available in Azure Functions as well.
Good question. Well, you can run your Azure Functions in two ways. You can run them in an Azure web app. Then I'm going to assume here, so assuming here, you probably will get a MSC Managed Service Identity as well, because you're really running them inside of the web apps. They're basically a web job with some bells around it. If you're running them on a dynamic plan, I honestly have no idea. Sorry. Yeah, sure. AWS has something similar. It's amazing. Well, thank you so much. Oh. Well, that's the funny thing about cloud. You can go to a meetup every evening and still learn something new. So, a lot. So, me having learned something only at 2/3, let's dive into the fourth approach. This is, in my opinion, by far the best. And that's, why do we have this secret that we have to retrieve from some location and then use at some other location? What if I, as an application, could just use my own identity, just go to the application? There's a thing called OAuth. There are things called bearer tokens. So we have the means in the world to have somebody authenticate somewhere else and just come to me with a verified identity and me allowing them access or not. And this is the best approach. And you will use it when you can give your application a runtime identity. So that's going to be managed service identity in Azure of a thing that I don't know the name of yet in AWS. And you're going to have a service that has to be able to receive such a form of authentication and do authorization based on that. And currently that's, as far as I know, probably correct again, Azure SQL DB, Azure SQL DW, Azure SQL Data Storage, and of course the Azure Management APIs. But maybe more. I have also good hopes that more will be added. But that's just hoping. So when would you use this? When you're allowed to, basically, and the service you're calling supports it. But nowadays, a lot of people are trying to move to microservices, right? So you have a lot of services calling other services, which people might call a monolith with latency. But you have probably a lot of services calling other services. And if there is a thing that you can implement on your own services, then it's this thing, accepting bearer tokens, and have your services calling each other using those tokens. So this is a thing where you can really leverage this approach. So let's take a look at what that looks like. And what I'm going to do, this code example shows, we can use the Azure Key Vault package to retrieve a token. And we can retrieve the token for a specific resource, which is in this case database.windows.net. And we can use in .NET 4.6.1 and up a new property on a SQL connection, which is called access token, to put on the bearer token. Then we do connection.open. That's it. No more secrets. It's amazing. This is the thing I wish everybody, because now you're completely done with all the hassle. And for more services, it's as simple as this. So, already spoiled a bit. No more secrets. It's amazing, but you're relying on MSI, which isn't GA yet, and you're relying on the service supporting it, which isn't just a small subset of services right now. So this is the fourth approach. So I hope you enjoyed your journey through these approaches. Let's just do a quick recap of what we've seen and what we can use when. First of all, there is this approach just handing it off to another team and letting them deploy it, where still some people are stuck. But I would never, ever advise that, and I would encourage everybody to try and move to a DevOps environment and a DevOps team. Now, if you're just doing continuous deployment of your code, use your release orchestrator to securely put in your secrets just in time. If you're also deploying your infrastructure in a continuous deployment way, use the secrets that are generated there, echo them into your application. If you're allowed to use non-GA stuff, and you're allowed to provision to the Active Directory, access the Key Vault directly from your application, because then it can refresh secrets and you're not stuck on rolling them by hand anymore, which I should have mentioned probably a bit earlier. And finally, if your service supports it, just use your own identity and directly call that service. So the managed service identity. Yeah. Of course, you can still use an app ID and a client secret if you want to. Then you get back to the secret. Where do you store that? So, a cheesy wrap up. Do embrace secret management. Do DevOps in a great and secure way. And I hope I have given you a step into the right direction. But thanks for your attention. And I think there's drinks afterwards. Thanks. Chocolate. Nice. Yep.
And I assume you like beer, so we have
yes.
beers for you.
Oh,
So
this
you
is.
can make your wife happy and be happy yourself.
Yeah, thanks a lot. Thanks, Eric.
Thank you very
You
much.
shouldn't. Thank you.
We will do the raffle